Okay, 8.3.1 to 8.3.10. I'm not going to talk about all of these. I think some of them are pretty straightforward. For example, this one right here is n is the number of variables, k is the number of variants. And we can see x1 times x2, those two variables multiplied by each other will give you only one variant, right? Because x1 times x2 is equal to x2 times x1. So that's just one variant, and no matter how you arrange them, you're only going to get one variant, so one distinct variant. So now we can look at this one right here, and we can see that this one is actually different, right? We can say that if we were to say that x1 minus x2 equals x2 minus x1, that's usually not true, right? So we would say that this is a distinct variant. So we can go through all these and talk about them, but I think the most interesting ones are this one and this one. So we'll talk about both of those. And so when we were talking about this one right here, what I did is I just chose some prime numbers, and I figured prime numbers were a good option. So what I did is I listed all the permutations of 2, 3, and 5. So there's 6 permutations. There's 2, 3, 5. Notice I just switched this 5 and the 3 compared to above. So 2, 3, 5, 2, 5, 3, 3, 2, 5, 3, 5, 2. So again, these just got switched. And 5, 2, 3, and 5, 3, 2. And so those are all of them. If you were to test them all out, you would get either a positive 6 or a negative 6 when you plugged them into this equation. So again, this is x1, x2, and x3. Okay, so when and the reason why is because notice here we get x1 minus x2, then x1 minus x3. So we just subtracted everybody from x1. Then x2 minus x3. So everybody got subtracted from everybody. So no matter how you orient this thing, everybody gets subtracted from everybody. However, this negative sign makes it such that you can get a negative and a positive based on these right here. So here, one of these is going to be positive, one of these is going to be negative. For example, here too, one of these should be negative, one of these should be positive. Okay, so the same thing exists here. We can get 2, 3, 5, 7, 2, 3, 7, 5. And this has a whole lot more permutations. I guess I won't list them out because it's too many, but 2, 3, 5, 7 and 2, 3, 7, 5 are going to be opposites. So negative 240 and positive 240. Now let me show you what I mean by you get the same values, or everybody gets subtracted by everybody and you'll get the same values. So look at this purple one right here. That's a 2. Here we get a positive 2. Here's a 4, 4. 2, you get this 2. 5, you get this 5. Negative 3, negative 3, 1, 1. So what you end up is all the same values. It's just that the positives and negatives can switch around. For example, well, the only one that was different here in this case was this negative and this positive. So everybody gets subtracted from everybody, and so you end up with the same magnitudes. However, you can get positive and negatives difference. So you can get the same magnitudes on all of them, but different values. Again, positive and negative. So the way to arrange this with this one, again, you can subtract everybody from everybody. So you can do x1 minus x2, x1 minus x3, x1 minus x4. Now, everybody got subtracted from x1. Now, let's subtract everybody from x2. So now x2 x3, x2, x4. Now we're done with that. And you might say, hey, what happened to x1 and x1 and x2? Well, that's over here. And then x2, x4, okay, so we left off there. Then x3, all we're left with is the x4 right here. So you might be saying, well, what happened to x3 and x2? Well, that was over here. So everybody got subtracted from everybody, and we end up with two distinct variants. Yeah. There we go. Oh, and another one. I think another one is kind of interesting too. This one right here. Check this one out yourself. And when you plug it in, when you plug everything in, you'll find that you end up with 3, which is kind of interesting too. Maybe well, you know what, you can do it. If you just do those prime numbers, you can check it. You'll see the nature of it. Well, okay, we'll do it right now. So 2357, 2375, we'll use those. So 2 times 3 plus 5 times 7, and you'll see, okay, that gives you the same thing as 2 times 3 plus 7 times 5. Okay, and then we could also do, well, this is going to take a while, but if you just keep testing them out more and more, you'll see that you can get 3 variants.